Hi guys, welcome back. In this tutorial, I'm going to talk about something which existed for quite a long time, which is the IoT and some protocol which is used in IoT called the MQTT. So people have done magic using MQTT by creating lots of cool projects. In this video, I'm not really going to use any things per se, but I'm going to take you through the basic concepts of MQTT, and we will create an app which uses this protocol, and we'll be using Kotlin for that. Yeah, and I have already done this in Swift project, so my aim is to clone that Swift project into Kotlin and take you through some of the cool libraries and cool concepts which you can use in your Android app. Yeah, let's start. Let's start with what is MQTT. MQTT stands for Message Queuing Telemetry Transport. This was created by IBM, I guess. It is a publish, subscribe, extremely simple, lightweight messaging protocol. It's designed for low bandwidth and constrained devices and for unreliable networks. The idea behind MQTT is to minimize the network bandwidth and the device resource requirements, so that like the bandwidth, the battery resources, etc. are used at the minimum, like sending small packages or small signals without putting lots of burden on the network or the resources, and hence enabling constrained devices to talk with each other. The main components of an MQTT, you can consider it as like there is the main guy called the MQTT broker, then you have a publisher, and you have a client. So MQTT broker is the central communication point in the MQTT LAN space. It is responsible for dispatching all the messages between the senders and the respective receivers. Let's say when a client publishes, or when a publisher publishes a message, it reaches the broker, and the broker sends it to all the receivers. So each client or each publisher that publishes a message to the broker contains a topic in the message. The topic is the routing information for the broker. So each client that wants to receive an update on a particular topic will subscribe to that topic, and the MQTT broker will push all the messages to all the clients that is subscribed to that topic. So that's how this the whole thing works. MQTT uses a TCP IP connection. Usually the connection is kept open by the client or the publisher to send or receive data at any point of time. There will be a keep alive signal which is being sent at regular intervals. Usually it is like 60 seconds by default. You can manipulate it. We will be seeing that later, how to do that. We have something important called quality of service. The quality of service is the level of an agreement between the sender of a message and the receiver of a message that defines the guarantee of whether the message is delivered successfully or not. So there are three levels: 0, 1, 2. 0 is called at most once. This is the least guaranteed delivery level. So there is no guarantee that the message gets delivered. It's like you can consider it as a fire and forget level. Then at least once, which is called QoS1. So here it makes sure that the message is delivered to the recipients at least once, and the publisher gets an acknowledge back. Then you have the highest level, which is like QoS2, which is called exactly once. Here the delivery is made sure, and it is made sure that it's delivered only once, avoiding duplicate or the same messages being sent to the client again and again. So these are the three quality of service levels used in MQTT. So I think these are the few core points with respect to MQTT. You have the publisher, you have the broker, you have the client, then you have the quality of service, then you will be subscribing and publishing messages through the TCP IP connection. That's pretty much it. I think you have got the crux of MQTT by now. If you want to read more on MQTT, you can go to IBM's MQTT Spec. I'll be providing the link in the description. And HiveMQ also has a nice course kind of thing called MQTT Essential. I will be providing that link also there. Like if you are curious, you can go and read more on that. Yeah, so let's finish up the theory and go to do some programming. Yeah, and as always, I have already created the project or the app in Kotlin. I'll be walking you through the core parts of the project, and I'll be providing you the link to the source so that you can go back and play around with that. Okay, let's start. Okay, in I have just opened the project. In this project we'll be using a library called Eclipse Paho as the client library for MQTT. In Swift we have used Cocoa MQTT, and there is another library called Cloud MQTT which is created by the Cloud MQTT team. So those are the two ones, and in the Java space the Eclipse Paho is mostly the well-known library. First you go to the project build gradle, you include the Maven repository link for the Paho, then you go to the app build.gradle, and you just need to include the Paho client and the Paho Android service. Then in the Android manifest you need to give the permission to the internet, access network state, wake lock, and add the Paho MQTT service as a service. So these are the steps just needed to include the library into the project. You don't need anything else. Now let's go and see how the UI looks like. So this is the UI for the app. Very simple. So you have a status bar area in which the status of the connection as well as subscription, publishing, etc. are being displayed. Then you have a field to enter the host name or IP address for your broker. Then you can enter the topic to listen. It can be anything like news or any text which all the parties understand. Then you have a text box to enter a message and send or publish. Then you have a connect button which makes the connection to the broker. Then you have a edit text box space which is used just to log all the messages. Like if two parties are being talking, it like a chat box, you can tell. So all the messages gets logged here. So this is it on the UI side. Then I have grouped all the MQTT core components into a class called MQTT Manager. Let's go and see what it has. MQTT Manager accepts something called MQTT connection params, the context, and then UI updater interface. Now what is MQTT connection params? It has nothing to do with the library. It is just a data class which takes in a client ID, host, then the topic name, and an optional, a username and password. you don't need to, I mean, it's not really an optional variable, but that values is not required. Right now I'm using empty. I'm not using any authentication per se in this project. So from the UI I'm just passing it as an empty string, or I'm not using it. Yeah, I mean, anyway, it's there. So when, if you want to have an authentication, you can use that. Yeah, and context is the normal context. Then you have something called UI updater interface. So what is that? So in this interface you have three methods: reset UI with connection, update status view, and update message. And let's see what each does. So the main activity conforms to the UI updater interface, and what this reset with connection does is, like, it manages the state of all the buttons, text fields, etc. in the UI. Let's say if the connection is false, the host name field or IP address field, the topic field, and the connection button will be enabled. Message and send won't be enabled, because you cannot send any message without connection. And if the connection is successful, then the IP address topic field will be disabled, and your message field and the send button will be enabled, and even the connection button also will be disabled, so that you don't keep pressing on the connection button just like that. So this is just to avoid all weird behaviors. Then update status view, it is just to update the top status bar with what is the current state. That's it. Then you have the update method, which takes in all the text, incoming and outgoing text, and try to put in like a chat log or something like that. You can say it as like a chat box. All the messages will be captured and dumped there. It's just to see that just as a logging mechanism, to see that you are receiving and you are able to publish messages. That's it. So these are the three methods, just to update the UI from your manager based on the state changes. Okay, now you have something called client, which is the MQTT Android client. This is part of the library, which takes in the context the host, then a client ID. So client ID is something like the unique ID, which uniquely defines the client. So I'm creating an ID here. So let's say first you will see, like, if the unique ID is not there, you try to fetch from the shared preferences. If it's not there, again you will be creating a random UUID, and in next restarts of the app we will be using the same UUID from the shared preferences. So that is the ID. Then once these values are provided, you get the client or MQTT Android client created, and in the init method we will be setting all the callbacks, like the connect complete, connection lost, message arrived, delivery complete, etc. So these two, like, as the function name suggests, it does that operation. Like, the message arrived is the main guy, which gives you whatever message is coming from the broker. It comes here, and I'm just updating the chat box or the log box with the whatever messages incoming. Now you have the connect. So in the connect you have something called MQTT Connect options. This is part of the library. So here you will be able to set the username, password, the connection timeout, keep live timeout, etc. So, like, if you like, okay, these are the properties here: MQTT version, clean session, keep alive interval. Like, if you go to keep alive interval, you can see that by default it is 60, connection timeout is like 30. So there's a possibility for you to change those here. So right now I'm these two lines are used to set the username and password. Right now I'm not using any username and password here. Yeah, and after creating the MQTT connect options, you will call the connect method in the client, which tries to connect, and you will be setting an action listener. Basically you have the success and failure, and once the connection is successful, you will be setting a disconnected buffer options. Basically this is the settings which governs the offline behavior of the app, like how much messages you need to buffer, so that when the connection is back, it can be pushed. So those are the settings that you are providing here, like buffer size, delete old messages, those kind of things. Then once the connection is successful, you are going to subscribe to the topic. So all the topic name, all the details are part of the connection params. So you just use that params object and get the topic, and then do the subscribe, and we'll see what is there in the subscribe. So once you call the subscribe, you will be calling the client dot subscribe, then pass in the topic, then the quality of service which we discussed earlier, and a listener, again success or failure. Like this just tells like whether the subscription was successful or not. Yeah. So once you are subscribed, once you are connected and you are subscribed to a topic, you are then ready to send messages. Okay. Okay, so when you click the connect button, so you will be first checking. Okay, the other part is like the host name. The Paho library expect to be in this format, like it should either have tcp : or ssl : then the host address and the port number, this which is ideally 1883. Usually a couple of systems which I have seen, it uses 1883. You can change it, you can probably set it as a param. Then you construct the MQTT connection parameters here. So here I just set the client ID as MQTT sample, but later in the MQTT manager you append a UUID to that so that it becomes unique. Then you call the connect method in the MQTT manager, which we have already seen. Okay, we have seen how the connect works. Now in the UI you have something called send message. Like when you type in something and click send, you will be calling the MQTT manager publish, and the publish method in the MQTT manager. So what it does is, like, first of all, like how the publish subscribe mechanism works is, like, even the sender who sends the message also get a callback, like, because he is also subscribed to a particular topic. So there is ideally no way to figure out who sends what. So usually the mechanism is like you embed the client ID into the message that you are sending, so that you uniquely identify. Obviously you don't prefer to the sender to get back the data he has sent and then use a manipulation. So usually not the case, because sender knows what he has sent. So to determine that, you can either embed the client ID or something into the message. Oh, here I'm just adding, like, okay, Android says, just like that. And maybe you can append the client ID also here, but just for this tutorial sake, I just add Android says, and later we will try to talk with an iOS app. So then you call the client.publish, then you pass the message as a byte array, then again the quality of service. Right now I'm keeping the base one. Then you have an action listener here, also again on success or on failure. Like if the message is published successfully, you get the success, else you get the failure, and you just update. Right now I'm just updating the status with the necessary states. So that's with respect to publish. So we have seen creating the Android MQTT client, setting it up, connecting to the broker, then publishing a message, and subscription by default. Yeah, and of course after connect you will be subscribing. Then all the callbacks which manages the connection state, and the message state is managed over here. Then you have a method to disconnect the connection. Right now I have not wired it with any UI elements, but if you want to use, this is how to use. Just call disconnect on the client. Then you have an unsubscribe also. Like if you want to unsubscribe from a topic, you just pass the topic name, and again it's the same thing. You will have a listener whether it is success or failure, then accordingly you handle it. Yeah, that's all with the core part of MQTT. Let's recap. You have an MQTT manager. You have to pass in the host details, which is either TCP or SSL with the host name and the port. Then you should have a client ID, which is which can be a unique UUID. With these three you will be creating a client. Then you are setting the callbacks for connection status and the message status. Then you are going to do a connection, actual connection, where in which again you can manipulate the multiple properties like keep alive, username, password, etc. After connection you will be setting the offline state properties like the buffer sizes, whether how much messages needs to be buffered offline, those kind of things. After connection is successful, you will be subscribing to a particular topic or the provided topic. Then you will be able to subscribe to the topic, and then you will be able to push messages to a particular topic. Then you have possibility to unsubscribe from a topic, then disconnect the connection. So that completes the whole cycle over here. Yeah, and that's all. Now let's run and see how things work. Okay, now we have the apps up. Just to make things interesting, I have just opened up an iOS app also, so that we will make the iOS and Android app talk to each other through the MQTT broker. Okay, so I'm going to type in the details of the broker here. Okay, so here I'm using the free broker service provided by HiveMQ. The endpoint is broker.hivemq.com, and I just provide the topic name as just 123, like random one. Now I'm clicking on connect, so you can see that the connection is successful and it is subscribed to the topic. Let's do the same in iOS. Yeah, so now it's connected. Now let's try to send a message. Just typing in hello. See, you can see that the message has gone from the Android to the MQTT broker and pushed into the iOS app. Now let's reply. So you can see that iOS says hello. So this way you can talk to two unrelated systems. The only thing that a client or subscriber or a publisher need to worry is the topic. Though, so for you, you know only it's the topic, you don't know what is on the other side. So that is the main advantage of this thing. Like two discrete systems can easily talk to each other. Yeah, so that's all I wanted to tell you all in this tutorial. So please go ahead and try this out. It's fun. So you can even set up something like this in a Raspberry Pi or connect some LCD display to the Raspberry Pi and then push some text through the Pi into the LCD display from your phone. So lots of interesting things can be done through this MQTT thing. Cool. So that's all, guys. So please, I'll be posting the source code in the description. Please check it out, try it out, have fun. Bye bye.